Welcome to this lecture. In the previous lecture, we have discussed about some MEMS actuators. In that, we have first started about different type of actuator principles like electrostatic comb drive, piezoelectric actuators, electrothermal actuators, and the magnetic actuators. Followed by that, we have discussed about the electrostatic comb drive, the magnetic micro relay, piezoelectric inkjet printer head. Now in this lecture we will discuss about electrostatic micromotors. It's one of the first electrostatic actuators that were designed. The principle of operation is center rotor that has a one type of charge, and the other there are the poles that are the different type of charges there. Here you can see in the diagram there are 6 poles are there, 1 2 3 4 5 6, 1 2 3 4 5 6. So 6 different static poles are there. So they will be charged with the opposite of that, the rotor charge. They will charge one by one. So you can see from this diagram that initially these two are charges 1 1, then the next, the second, these two poles, this will charge, so it will rotate in the direction and it will align with these two static poles. Next, after 2, the third number of static poles will be charged, so it will be aligned with the third one. So in this manner this rotor will rotate in a particular direction. This is the actual diagram for the electrostatic micromotors, where you can see these are the stators. This is a 3-pole stator motor, and this is the rotor. This is the hub for this one, and this rotational energy is transferred to this gear. So as this rotor will rotate, in that case the gear will also rotate, so we can transfer this rotating energy for further applications. Next is digital micrometer devices, that is also known as DMD. It's first designed by the Texas Instruments. It contained 1 million tiny pixels of micrometers, each size of about 16 micrometer by 16 micrometer. It can rotate by plus 10 degree and minus 10 degree over 1000 times in a second. When light from the projection source impinged on the pupil of the lens, or you can say the mirrors, and it reflected brightly onto the projection screen. We will see the principle later. The DMD, digital micrometer devices, are used for display for the PC projectors, high definition televisions, HDTV, and for large venue such as the digital cinema, where the traditional liquid crystal technology cannot be complete. MEMS has enabled the micromirrors to be only 1 micrometer apart, resulting in an image taking up a larger percentage. So the micrometers are the sizes of already we said that the sizes are about 16 micrometer by 16 micrometer, and they are placed by 1 micrometer apart, and million of tiny micrometers are there. So we will get a resolution about 89% space is covered, only 11% space is remaining there. So the resolution is very fine in this case in compared to LCD. This reduced the pixelation and produced an overall sharper and brighter image. This is the principle. We can see these are the micromirrors. This is the micromirror. These are the hinge, torsion hinge, where this micromirror will move by 10 plus 10 minus 10 degree. These are the electrodes. So it will charge, they will attract or repel this micromirror in this direction. So it will move in this direction. You can see with this image also, this is the hinge, so it will just lie in that, it will move up down, this portion and this portion. These are the electrostatic poles. So this is the principle, where this is the light source. Light will come from this light source over all these micrometers. It will reflect the light coming from the source towards this projection lens or towards the light absorber. If it will reflected in the towards the projection lens, we will see in the output on the screen, and in case it is reflecting the light towards the light absorber, we will get the zero output here of dark. So this is light absorber, so whatever light it will be absorbed, it will reduce, it will not allow to heat it up. So this is known as light absorber, and also it will not allow to reflect again the light. So it's a complete black body we are using here. These are the 3 DMT micrometers we are showing here, but it's a very large number of micrometers actually it's contained. You can see this is the TLP projector chip. This is the chip completely is using this memory, processor, all this structure, and the light is coming from this one and reflecting this. For different color light, different micrometers are available. So the light source is common, but because of the reflection from the micrometer, micromirror, different color on the screen we can see. This is digital micrometer device. DMT is also used in the optical communication, where it's used for switching the signal from one optical fiber to another optical fiber. We can see here, if these are the micromirror array, if it is it will be in this direction, so it will reflect the light here, and if we will change the rotation angle of this micromirror, that will be changed, and it will change the direction of the reflected lights. So this is the micromirror one, and this is rotation direction. This micromirror can rotate in the 2 directions. You can see from here. It's a this is XY movement, and in this direction also it can be moved. This is all about the digital micrometer mirrors. In the next lecture, we will discuss about some smart material devices. Till then, thank you.